Okay, today we're going to talk about rational functions. Before we do that, let's talk about what is a rational function. So it is nothing more than a function that is a ratio of two polynomials. So if you look at the example here, you have a polynomial in the numerator and a polynomial in the denominator. So really, you can think of a rational function as something that will have a variable in the denominator. All right, so let's talk about operations with rational expressions. First of all, let's talk about reducing. Now, you've really done this already in Algebra 1. You might not have called it a rational expression, but it has a variable in the denominator, so it really is a rational expression. And you already know how to reduce this, right? You're going to reduce all the common factors, right? 12 divided by 6 is 2. You're going to take x to the fifth divided by x to the third, so you're going to subtract those exponents, and y squared minus 8 will give you a negative 6, so the y to the 6 will be in the denominator. Now, when you have something like this, the first thing that you're going to want to do is to factor. So always when you're working with rational expressions, you're going to want to factor the numerator and factor the denominator whenever possible. All right, so when I factor the numerator, I get x minus 6x plus 1. And in the denominator, I can factor out a 2, and then I'm left with the difference of 2 squares, so I can make it x plus 1, x minus 1. When I do this, you can see that x plus 1 in the numerator and x plus 1 in the denominator will cancel out. So when I simplify it, I'm just left with this expression. Go ahead and get out a pencil and paper and try a couple of these on your own. Why don't you pause the video and try this, and then I'll start it up again when you're ready to see the answer. All right, let's take a look at how to do this. X plus 1 divided by x minus 4 is the answer. You need to factor the numerator and factor the denominator. The x minus 3's cancel out. On the second one, number 4, you get x plus 3 over 2x minus 1. Again, factor the numerator, factor the denominator. The 2x minus 5's cancel out, and you're left with x plus 3 over 2x minus 1. All right, let's see how much factoring you remember. Go ahead and try this one. All right, so the numerator now has 4 terms. So if you remember from our polynomial unit, we can try to factor this by grouping. And when you do that, you will end up with x plus 3, x minus 3 times x plus 2. And in the denominator, you can factor out a 5 and then continue to factor. When you do this, you will see that those x plus 3's will cancel out, and then you're left with this expression. All right, let's talk about multiplication. So now here I have 2 rational expressions, and I'm multiplying them together. Again, this really isn't anything new. You've done this already. Right? First thing I would do is cross-reduce all of my numbers. So 7 goes into 28 4 times. And then I'll simplify this. I guess I'll simplify the numerator and the denominator first. So a to the third times a would be a to the fourth. And b times b to the negative 6 would be b to the negative 5. And then the denominator, a to the fourth times a to the fourth would be a to the eighth. And b to the minus third times b to the fourth would be b to the 1. I need to continue to simplify, and I'll end up with this expression. All right, pause the video and see if you can do this one. Did you get 3x minus 1 all quantity squared over x? All right, so in this first one, you can factor out a 3x, and when you do that, you are left with the difference of a perfect square, so 3x plus 1, 3x minus 1. You can go ahead and factor 3x squared minus 4x plus 1. And in the denominator of the first one, you can factor 3x squared minus 2x minus 1. And then if you take a look, I can cancel out 3x's plus 1, the x minus 1. And in the numerator, I can cancel out the whole 3x, but in the denominator, I'll be left with just x. All right, go ahead and try this one. All right, so now you're going to see this one here involves kind of a lot of things you need to think about. In this first ratio, in the denominator, you're going to have to factor using the difference of a perfect cube. And over here, you can see you have x minus 2, and then in the denominator, you have 2 minus x. So all you really have to do is factor out an x for this one, and then you can cross out those x minus 2's. And when you do that, you will be left with a negative in the denominator, which we would never leave a negative in the denominator. So you can pull it up into the numerator or put it out front. Either way is fine. All right, let's talk about division. All right, so here I have two fractions that are divided by each other. And if you remember, when you are dividing fractions, you take the second fraction, you flip it and multiply. Once you do that, you're then going to factor and complete it as if it was a multiplication. All right, so I'm going to go ahead and factor. I already flipped it here, so the 3x goes in the denominator, and I factored x squared minus 4x plus 3. And now that you've done that, you can go ahead and cancel anything that cancels out. Again, in this numerator, you have 2 minus x, and in the denominator, you have x minus 2. So if you multiply through by a negative, it'll flip this around and let you cancel it. And you'll have negative x minus 1 over 3. Negative 2x minus 1 over 3. Go ahead and try this one on your own. All right. So you're going to flip the second fraction and change it to multiplication. Go ahead and factor everything. Here your x minus 2's and your x plus 3's cancel, and you're left with 3 over 4x. All right, so now here I have division and multiplication. All right, so let's go ahead and factor and flip this middle one, because the middle one will then have to become multiplication when I flip it. And I factor everything. Now you need to look to see what cancels out. The x plus 3's will cancel out. The 4x plus 1's cancel out. And you're left with x minus 3, and a 4 times 4x minus 1.